Okay, everybody, so let's take a look at today's lesson, okay? So, first of all, our objective today is to be able to add or subtract what we call radical expressions. Radical expressions. Now, the term radical means root, okay? They must be the same. So here's the rule. They must be the same. Like 3 squared to 2 and 5 squared to 2. They are the same. And like 3 squared to 3 and 4 squared to 3. They are the same. So I can add them. So all right, let's go ahead and go through and add these. I'd have 3 squared to 2 with 5 squared to 2 just makes 8 square roots of 2. How many of these? How many square roots of 2 plus how many square roots of 2? 8 of them. And 3 square roots of 3 plus another 4 square roots of 3 just makes 7 square roots of 3. That is it. That's all you got to do. Pretty simple, hopefully. Okay. Now, in example 2, it does not look like they're the same, but we need to reduce them first. Okay, so let's real quickly go back through our perfect squares or perfect cubes. So we do know that yes, we have perfect squares. Okay, perfect squares. Yesterday we talked about, 4, 9, 16, 25, 36, 49. Let's see, 64, 81, and let's talk about. So then we could do these, okay? So we try and reduce this. We have a square root of 2 times the square root of 25. Well, why do we do that? Because square root of 25 is 5, and we can then make this a 5 square root of 2. Square root of 18 is going to be, well, let's see, how about the square root of 9 and the square root of 2? That's a perfect square root. And then when I add those, I can make this into a 3. So I'll get plus a 6 square root of 2. And then square root of 8 is the same thing as plus a square root of 4 square root of 2. Square root of 4 is 2. 2 times 2 is 2. 2 square roots of 2 is 2. Now, I can add these. 5 square root of 2, 6 is 11, 12, 13. I can get an answer of 13 square roots of 2 because I can add them after I reduce them, okay? Okay, let's look at example 3. Example 3, they're perfect cube roots. So let's write those down. Perfect cubes. Yesterday we talked about 8, 27, 64, 125, 216, and so forth and so on. Okay, those are my perfect cubes. So at first we can't add them, but we can break these down. Sorry, squished this, make room for here. So I'm going to rewrite this as the cube root of 27 times the cube root of 2. Why? Because the cube of 27 is just a 3. And then I get 3 times square root of 2, and I get 3 cube roots of 2. Okay. Cube root of 16, I'm going to rewrite that as the cube root of 8 times the cube root of 2 because the cube root of 8 is 2, and I'll have plus a 2 cube root of 2. Okay, those are the same. That's good. And then finally, 128 could be, let's see, 128 I think is 64, isn't it? Cube root of 64 and cube root of 2. All right, the reason I did that is cube root of 64 is got to be a 4. So plus 4, and I'd have a cube root of 2. Now I can add them. 3 plus 2 is 5, and 4 more makes 9. I'd have 9 cube roots of 2. All right, got it. All right, now, all right, let's keep going with this. Perfect force. We didn't write those down, but my perfect force, I can write those down also. Perfect force. Might help me. Perfect force. We wrote down as 16, 81, and 256 and 625, and beyond that doesn't really matter, okay? Now, number 2, excuse me, example 4. Square root of 25 is just 5, that's easy. 2 times 5 is 10, plus, oh, these are easy. Cube root of 125 is 5, so I'll have a plus 3 times a 5, plus 6. Oh, 4 through 16 is 2. I know that one. That's perfect root. Let's see what I have. I've got a 10 plus a 15 plus 12. Whole numbers. Let's see. That's going to be a 25, a 37, plain old 37. We can add them all because they're the same. Okay, example 5. Well, square roots, cube roots, square roots, whatever. Okay, well, let's see what happens, okay? All right, 2 times, let's see, 40 is going to be the cube root of 8 times the cube root of 5. Again, I'm just trying to find perfect cubes, and there it is, okay? Minus 5 times the square root of 25. Let's go square root of 25. Square root of 5, because that's a perfect root. Now, 405, oh, I don't know, but maybe I can find it. Okay, so let me grab a calculator and see if I can find this one. So let's see, 405. If I divide 405 maybe by 81, I don't know, let's check it out. I'm looking for some of these. Looking for any of these. Let's check 405. 405 divided by, let's try 81. Ah, it works. 81 of 5. Okay, so the 4th root of 81. 4th root of 5. Let's see what I get. Okay, so then this becomes a 2. This becomes a 5. This becomes a 3. And so then I'll have a 4 cube roots of 5 minus 25 plus 12 4th roots of 5. They're all different. So I cannot add them. That's it. That's the answer. They're all different. That is my answer. Okay? All right, now, again, let's see what we can do. Example 6. All right. I'll change 24 into 8 and 3. So I've got a 4 times the cube root of 8, because that's a perfect cube, times the cube root of 3. All right? Minus 5, that's a square root, so square root of 25 and 5, plus 4 cube root of 125. It's got to be one of these. 135. Let's see, 135. I'm going to divide by 27. Let's see. Aha, it is 27. Okay, so cube root 27, cube root 5, and then minus 10, square root of 9, square root of 3. Okay, so let's see if I can simplify this. Okay, let's see what I got. I got a 2, cube root of 8 is 2. I've got a 5, square root of 25 is 5. I've got a 3, cube root of 27 is 3. I've got a 3, square root of 9 is 3. Okay, so then let's see if I've got an 8, cube root of 3, minus a 25, square root of 5, plus a 12, cube root of 5, minus a 30, square root of 3. Okay, let's see, what's the same? These two are the same. I can add those. It's a 20. Cube root of 3. All right. These two are the same. Let's see. What is that? Minus 55. Minus 55. Oh, no, they're not the same. They're not the same. Stop. Stop. 25. Nope, they're not the same. 25 square roots of 5 minus 30 square roots of 3. Not the same. Okay, and then that is the answer. All right, almost made a mistake. That's typical of me, okay? All right. Turn the page. Let's see what I got. Okay, now, simplify roots with variables. Okay, so here's what I know. I know that x to the 4th times x to the 4th equals x to the 8th. So the square root of x to the 8th is just take half the exponent, and I get x to the 4th. Boom. Okay, now if I want to take half the exponent, what I need to do is make this an even power. So I rewrite this as x to the 8th times x to the 1, because I can take half the exponent. So I'll get an x to the 4th square root of x. Okay, this one, 10 I am going to reduce this one, square root of 4, square root of 3, because I'm doing square roots, and I need to make this an even exponent. So I'll make this a square root of x to the 8th and a square root of x. Okay, now, square root of 4 is 2. I take half that exponent, I get x to the 4th. And these two I can't do anything with. They have to stay inside the square roots. So there's my answer. 2x to the 4th, square root of 3x. Okay, there's my answer. Okay, now, cube roots. We want to take a third. We want a third. We want a third of the exponent. Now 54 I can break down. Let's do this. Okay, let's go write it down here. Okay, 54 cube root 27 cube root of 2, because I can still reduce this. And then if I take the third of that, so I want to take a third of that. So first of all, 3. And then I'll take a third of that. I'll make it x to the 4th. And then cube root of 2. That's the answer. Simplified as much as it can be. Last but not least, you bet we're going to take a fourth. We're going to take a fourth of the exponent. So let's see, 162. 5 times the 4th root of 81, 4th root of 2, 4th root of 8, and I will take a fourth of that. That'll be x squared. Now this one we're going to have to change. So we're going to take it to the 4th root of y to the 8 with a 4th root of y to the 3rd. Okay, there's my 11. Okay, there's my 11. Okay, now I can take a fourth. I'll take a fourth. So let's see what I have. Okay, so first of all, that makes a 3. I'll take a fourth of that, x2. Take a fourth of that, y2. Now what's left over? 5 times 3 is 15. X squared, y squared, and I'm left with a 4th root of a 2 y to the 3rd. Okay, that's kind of hard, but we're approaching how to do that later, okay? There you go. That's all I have. Big lesson.